Again, welcome to pre-calculus class. In this class, we're going to talk about integer exponents. Again, this is also a college algebra topic. So our main objective is to simplify algebraic expressions with constant or single variable basis using the property of integer exponents. So first, we start with the zero exponent. We know that any value or any variable raised to the power 0 is always equal to 1. So here we say that a to the power 0 is equal to 1 for any non-zero number or non-zero algebraic expression a. So again, any value or any variable, in this case a, raised to the power 0 is always 1. Now, we should know that 0 raised to the power 0, there's no answer, it's undefined. So again, that's our first rule. Now we'll go through the positive integer exponents rules. So here we say that suppose a is any non-zero number. So a can be any value, whether positive or negative, but it's not 0. So suppose a is any non-zero number or non-zero algebraic expression, such as a raised to the power 1 is the same as a. So anytime we have a value raised to the power 1, the answer will give us the same value. Or a variable raised to the power 1, the answer will be the variable. So a raised to the power 1 is a. A raised to the power 2 is the same as saying a times a. Or in this case, we say a times a raised to the power 1. So anytime we have a raised to the power n, it will be a times a raised to the power n minus 1. The reason why we are using minus 1 here, because again, we remove 1a out. So a raised to the power n is the same as writing a times a to the power n minus 1. Or we can also say a times a raised to the power n minus 2, because we have 2 a's out. So in a very simple way, we can say a times a is the same as a squared. Then a times a times a is the same as a cube, and so on. Next, we go to the negative integer exponents. So here we say that if a is not equal to 0, then a raised to the power negative n. So n can be any value except not 0. So a raised to the power negative n will be 1 over a to the power n. So this means anytime we have exponent negative, we find the reciprocal of that value or that expression and remove the negative. So for example, 5 raised to the power negative 2, the answer will be 1 divided by 5 raised to the power 2. So again, a raised to the power negative n, the answer will be the reciprocal of a raised to the power n, or 1 over an. And as we said earlier, 0 raised to the power 0 is not defined. But 0 raised to the power n, for example, 0 raised to the power 1, 2, 3, or any value, the answer will be 0. But 0 raised to the power 0 is not defined. So again, we went through some few rules. Now let's try to solve some problems here. So here we are going to write the following numbers without exponents. So 3 to the power 4 is the same as writing 3 times 3 times 3 times 3. So let's see the solution. 3 to the power 4 is equal to 3 times 3 times 3 times 3, which will give us 81. Then 2 to the power negative 3. First, we can remove the negative by getting 1. The answer will be 1 over 2 to the power 3. Then finally, 2 to the power 3 is the same as 2 times 2 times 2. So the answer will be 1 over 2 to the power 3 to change the negative. Then we have 1 over 2 times 2 times 2. So finally, the answer will give us 18. C gives us 4 divided by 5 to the power negative 1. So since again 5 is raised to the power negative 1, the reciprocal of it will give us 1 over 5 to the power 1, which means we will bring the 5 up. So we are going to get, so here we have 1 over 5. So we will bring the 5 up. So we get 4 times 5 divided by 1. This is a fraction rule. So in a fraction, if we have two fractions dividing, if we change the sign to multiplication, we are going to turn the following fraction upside down. So the division here, 4 divided by 1/5, change to multiplication. So we get 4 times. So we have to turn our 1/5 to 5/1 upside down. So the answer will give us 20. Then we have D. D is negative 4 to the power 4. So this means negative 4 times negative 4 times negative 4 times negative 4, 4 times. And one thing we should notice here is that anytime we have a negative value raised to the power and the power is even number, the answer will be positive. So negative 4 raised to the power 2, the answer will be positive 16. Same thing applies to negative 4 raised to the power 4. Whatever answer we get, it will be positive. Negative 4 raised to the power 6, it will be positive. Always if the exponent is even number and the value is negative, automatically will be positive answer. But now if we have negative 4 raised to the power 3 or raised to the power 1, the answer will be negative. So if the exponent is, the exponent again is an odd number, then the answer will remain negative. So here we're going to get a positive answer, which will be 256. Now in next question, the previous question, we have a parenthesis. So the negative 4 affects, the exponent 4 affects the negative and also the 4. But this time we don't have no exponent, which means we don't have no parenthesis, which means the exponent 4 affect only the value 4. It doesn't affect the negative. So the answer here will be negative. Again, here we have a parenthesis before the exponent 4. So the exponent 4 affects both the negative and the 4. But here, the exponent 4 affects only the 4. So our negative will remain. So our answer will be, again, negative 256. So let's go through some of the properties of exponent. So here we are assuming the A here can be a value, it can be a variable. But now if I have two items multiply and the base are the same, so here if it's 2, or A, or X and X, if the base are the same, we had the exponent. So A to the power M times A to the power N, the answer will be AM plus N. Now, if it's A to the power M times B to the power N, we cannot do anything. The answer will be AM, BN. But here, since the base are the same, we had exponent if we are multiplying. The second rule, we went through that already. Any value raised to the power 0, the answer is always 1. Whether it's a value or a variable, the answer is always 1. Now here we have A to the power negative 1. We went through this. This means we have to find the reciprocal of the value. So it will be 1 over A. Now A raised to the power negative N, it will be 1 over A to the power N. Then this time we have a division. The base is the same. A to the power M divided by A to the power N. The answer will be A, M minus N. Then question number 6, we have root of NA. So we know that a root always will be a reciprocal of that root. So root NA is the same as writing A to the power 1 over N. So if it's a square root, it will be A to the power half. If it's cube root, it will be A to the power 1/3. So root NA is again A to the power 1 over N. Then we have number 7. Now, if we have an exponent raised to another exponent, raised to another exponent, as many as we can, always we multiply all the exponents. So here we have a to the power m to the power n. So we are going to multiply m and n. So the answer will be a raised to the power m and n. 8, we have a, b, n. The answer for this means the exponent n affect both a and b. So the answer will be an and bn. Same thing applied to division, a by b, everything n. So which means the n affect both a and b. So we get a to the power n divided by b to the power n. So we have another example here, positive exponents. So for example, if I have a question, s to the power 3 times s to the power 5, again, we are going to add the exponent. So we are going to get s 3 plus 5, and that will give us x to the power 8. Here we are using the property number 1 from the previous slide. When we have multiplication of 2 items or more items, but the bases are the same, add all the exponents. Second question, we have a division. But this time we have a y to the power negative third square divided by y to the power negative 8. So the first thing I will do is to remove the parentheses. So I'll get 2 times negative 3, which will give us y to the power negative 6 over y to the power negative 8. Again, first thing I'll do is to remove the parentheses. Negative 3 times 2 will give me negative 6 divided by y to the power negative 8. Now we know negative, we have to find the reciprocal of that value. So y to the power negative 6 have to come down, but y to the power negative 8 also have to go up to have both positive. Or another option we can do, since we are dividing, we will say y equal to the power negative 6 negative minus negative 8. So we can write it as negative 6 minus negative 8. We know the property that if we are dividing 2 items and the base are the same, if they have exponent, we are going to subtract the denominator exponent from the numerator. So we get negative 6 minus negative 8. And this will give us negative 6 plus 8, because negative times negative is positive. So we get again negative 6 plus 8, which finally will give us y to the power 2. So let's try number 6. We have y to the power negative 2 divided by y to the power negative 6 all raised to the power negative 2. So the same thing, we use the rule for multiplication first. So negative 2 will multiply negative 2 at the numerator. Then negative 2 will multiply the denominator exponent negative 6. So we know negative times negative is positive. So we are going to get y to the power 4 divided by y to the power 12. Because 2 times 2, negative 2 times negative 2 is positive 4. Negative 2 times negative 6 is positive 12. Then if we like, we can reduce it, because 4, we are dividing. So 4 minus 12 will give me y to the power negative 8. Because again, we have to subtract the denominator exponent from the numerator. So it will be 4 minus 12, which will give me negative 8. Then the negative will change to positive, so it will be 1 over y to the power 8. Or here we are going to use a different sequence of step. So we have the question again is here. The next thing I'll do, instead of again multiply the exponent first, I can simplify the bracket first. So this will be y to the power minus 2 minus 6. And that will give me 4. Minus 2 plus 6 will give me positive 4. Then I'll multiply positive 4 by negative 2. That will give me negative 8. Then I can bring the negative 8 down. So either method will work. Here, the first method, I use the exponent negative 2 to multiply both the numerator exponent and the denominator exponent. Then we continue from there. Or I can just simplify the parentheses first, then I will multiply the exponent later. So let's try example number 3. Here now is getting a little bit complex. We have 2x cubed times 6y divided by 4xy to the power negative 1. So we remember that only the same base we can work on. So x cubed and x, it will be 3 minus 1. So it will be left with only x squared at the top. Then here we have y, and here we have y negative 1. So it will be 1 minus 1. So y will be 2. Then we can cancel 2, can go into 4 is 2. So this is division, so we can cancel. So let's go through the steps. This is the question. So the first thing we did here, we multiplied 2 and 6. We get 12x cubed, y, then 4x, y to the power negative 1. Then we bring everything up. First of all, 12, as we said, 12 and 4 we can cancel. So 4 will go into 12 is 3. Then I have s to the power 3. The down is 1 and is dividing, so it will be 3 minus 1. Then we have y to the power 1. The down is negative 1 and is dividing, so it will be minus 1. So we know the division rule, the same base. We subtract the denominator exponent from the numerator. So we get 3s to the power 3 minus 1, y to the power y minus 1. So finally, our answer will give us 3s squared and y squared. Let's try another one. So here we have 8x y to the power negative 2 divided by 2s squared y to the power negative 2 also. So here, since we have negative 2, the same power, the same exponent, we can cancel the 2. That will be the quick way. And also 2 can go into 8 is 4. Then here we have x, 1 minus 2. So we get 4x to the power negative 1. So finally, our answer will be 4 over x. But let's go through the steps. So first, what we did, 2 can go into 8 is 4. We have x, 1 to the power 1. Then denominator is 2, so it's 1 minus 2. Then y, we can cancel, but here we decided to write it y negative 2, negative 2. So that would be negative 2 plus 2, which will give us 0. Y to the power 0 will be 1. So it's the same as cancel it to be 1. So later we get only 4x to the power negative 1. Then later the answer will be 4 over x. So again, 2 can go into 8 is 4. The denominator have positive 2 exponents, so it will be 1 minus positive 2, which will be 1 minus 2. Then the y to the power negative 2 and y to the power, so they will cancel each other. Or we can write y to the power negative 2 minus 2. Then later minus and minus will be plus, so we get minus 2 plus 2 will give us 0. Y to the power 0 will be 1. And 1 minus 2 will be negative 1. So finally, our answer will be 4x to the power negative 1, which is the same as writing 4 over x. So another question given here, we're given this expression. Again, the best way to solve this, we can simplify inside first. Then when we finish, we multiply the exponent negative 3 by everything inside. Or we can use the negative 3 to multiply everything inside, then we simplify. So the solution here, we decided to simplify everything. We have 3 will remain, only 3, but we have a divided by a to the power negative 2. So that will give me 1 minus 2. Minus 2 will be plus 2, so it becomes 3. Plus 2 plus 1 is a to the power 3. Then b, we have b to the power negative 3 minus positive 3. So here we have b minus 3. So that will give me, again, the 3 is positive, so minus positive 3. So positive and negative will be minus, so we get minus 3, which will give us minus 6. Then everything raised to the power negative 3. Now we can multiply the negative 3 by everything. So we get 3 to the power negative 3, a to the power negative 9, because negative 3 times 3 is negative 9. Then negative 6 times negative 3 will give me positive 18. Then this will give me 3 to the power negative 3. We can bring it down. And 3 to the power 3 is 27. The reason why we bring it down, so we change the negative. If we like also, we can bring the a down to be a to the power 9. Then only b to the power 18 will remain top at the top. At the moment, this is correct. A to the power negative 9, b 18, 27. So that will be the conclusion for these lectures. Again, these lectures, we went through the concept of exponents. So we went through the rules of exponents, and this is again normally a college algebra class, but this course is calculus. We are starting with some review of college algebra before we start the calculus topics. So again, wish everybody the best, and thank you.